Hi everyone, in this video I'm going to solve Cambridge International AS and A levels Mathematics Pure Maths 3 Paper 3-2 in a session February-March 2022. So let's start with the first question. Question number 1, solve the inequality. Okay, so when I open this absolute value function, we will get plus minus 2x plus 3 is greater than 3 into plus minus x plus 2. Right. Now we have to do scaling on both sides. To get rid of this plus minus sign, right? We have 2x plus 3 whole square is greater than 3 square x plus 2 whole square. So we have 4x square plus 2ab. So we have 2 times 2 times 3. We have 12x. And 3 square is 9. This is greater than 3 square is 9 into x square plus 4x plus 2 square is 4. Okay. 4x square plus 12x plus 9 is greater than 9 is going to multiply inside the bracket 9x square. 4 times 9 is 36x plus 36. Right. Now we have to shift all the terms to the left side. 4x square minus 9x square plus 12x minus 36x plus 9 minus 36 is greater than 0. Okay, now 4 minus 9 is minus 5x square, 12 minus 36 minus 24 x, and 9 minus 36 is minus 27 is greater than 0. Let me take negative sign common. So we have 5x square plus 24x plus 27. This is less than 0, right? Because multiplying with a negative sign, we have to reverse the inequality. Okay, so this is a quadratic equation. So let me solve this by using a quadratic formula. So x is equals to negative b, that is negative 24, plus minus square root 24 square, minus 4 times the a value, that is 5, and the c value, that is 27. And this is going to divide with 2 times of 5. Right. Now x is equals to minus 24 plus minus square root. Square of 24 is 576. And minus 4 times 5 times 27. Sorry. Times 27. This is minus 540. With the square root. And this is going to divide with 2 times 5 is 10. Right. Now further simplification, we have x is equals to minus 24 plus minus square root. We have 576 minus 540, 36. And 36 is a perfect square. So this is 6 square is 36. So square root of 36 is 6. So x is equals to minus 24 plus minus 6 divides, sorry, it's 10, the denominator. It's 10, right? Now we have two values for x, right? With a positive 6 and with a negative 6, right? So x is equals to minus 24 plus 6 over 10. And x is equals to minus 24 minus 6 over 10. What are the two x values? Let's see. Okay, minus 24 plus 6 divides 10. This is minus 9 by 5. Right, and the other is minus 24 minus 6 divides 10, which is minus 3. Right. Okay, now let me draw this quadratic curve. Okay, if I draw this curve, okay, so we know that both the roots are negative. What is minus 9 by 5? This is minus 1.8. Okay. This is minus 1.8. One root is minus 1.8, the other is minus 3. So the parabola shape look like this. This root is, let's say, -3, and this root is -9/5, 1.8, right? Okay, now the curve, the equation, it says, as you can see, the x square coefficient is positive. Since it is positive, so the opening of parabola is upward, and we have to find the roots when the curve is less than 0, right? So the curve is less than 0 in this region, right, and it is greater than 0 in this region. So between -3 to -9/5, the curve is less than 0. The x values are less than 0. So we can say that the answer is the curve is less than 0. The inequality satisfied when -3 is less than x is less than -9/5. Question number 2. On the sketch of Argand diagram, shade the region whose points represent the complex number z, satisfying the inequality absolute of z plus 2 minus 3 iota is less than equals to 2, and argument of z is less than equals to 3π/4. So what is this? This is the equation of circle in a complex plane, and this is the equation of line, right? So first let me simplify the circle. The equation of circle in a complex plane is basically absolute of z minus -2 plus 3 iota is less than equals to 2. So we have absolute of z minus z naught is less than equals to r. So z naught is the center and r is the radius, right? Okay. So now the second thing is the line. Let me simplify the line as well, and then we can draw the sketch. And so the line is argument of z. So what is argument of z? Argument of z is basically tangent inverse of y over x. This is less than equals to 3π/4, right? So we have y over x is less than equals to tangent of 3π/4. So let me simplify tangent 3π/4 in radians. The calculator is in radians. So tangent this is pi over 4, -1. So y over x is less than equals to -1, and y is less than equals to -x. This is the equation of line, right? Okay, so now let me sketch this Argand diagram. Okay, so in a sketch, okay, so if I numbered these points as centimeters, okay, we need 1, 2, 3, 4, 5, and at the bottom we have -1, -2, -3, -4. Okay, because the denominator we need -2 and 3. Okay, that's fine. And the rest of the values on x plane are, okay, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. Okay, so this is the real axis. Okay, and this is the imaginary axis in Argand's diagram, right? Okay, let me sketch the circle first. The center of a circle is -2 and 3, right? So x value is -2 over here, and the y value is 1, 2, and 3 is over here, right? So let me sketch the center of a circle first. Let's say this is a center of a circle, right? And the radius of a circle is 2. So 2 units from all the 4 sides. So this is the radius, right? And we have 2 units over here. Okay. And we have to move 2 units down and 2 units up. Yeah, it's just a rough sketch, right? So now let me connect all the points by using a compass and draw the circle with a radius 2. Okay, so at the center, this is a sketch of a circle. Okay. Right. Okay, so this is a sketch for a circle. Okay, now the next thing is, this is the center, right? We have 3 and -2. Okay, now let me draw the line y equals to -x, right? So as we know that this line shows y equals to x. When x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, and so on. And this line shows y equals to -x, right? Okay, how can I sketch this line? So when y is 1, x is -1. So if I draw this point over here, y is 2, x is -2, y is 3, x is -3, y is 4, x is -4, and same on the other side, right? So let me sketch this line passing through the origin. Okay, so this is a line for y is equals to -x, right? Now we have to shade the region. So as you can see, for circle we have less than equals to 2, so the boundary and the inner portion is shaded, right? And for line we have y is equals to x minus x, this one, and y is less than -x, so the upper portion is shaded, right? So the only shaded region we can say that satisfies the both is this, inside the circle and above the line. This is a shaded region. I hope this is clear now. Right. Question number 3, the variables x and y satisfy the equation x power n y square equals to c, where n and c are constant. The graph of ln y against ln x. ln y against ln x is a straight line passing through the points. We have given 2 points as shown in the diagram. Find the value of n and the value of c correct to 2 decimal place. Okay. So we have this equation. So I have applied the natural log on both sides. Ln of x power n y square equals to ln of c. Then I just open the product rule of the natural log with the sum, right? Now power comes before the natural log, and 2 ln of y, this is equals to ln of c, right? Okay, so it is a straight line, and we know that the equation of straight line is y equals to mx plus c. But in the when y is ln y and x is ln x, we have equation ln of y equals to slope times ln of x plus some y-intercept, right? Okay, now if I can solve ln of 2 ln of y equals to minus n ln of x plus ln of c, we have ln of y equals to minus n by 2 ln of x plus 1 by 2 ln of c, right? Okay, so this is equation of straight line, and we have a slope of, this is the slope and this is my y-intercept, right? Okay, so if I I'm sorry, yeah, the y-intercept. So let me plug the 2 points. This, the first point is your ln x and second is ln y. This point is ln x and this is ln y, because the x is ln x and ln y, right? Okay, so let me plug the first point, 0.31 and 1.12. 1.12 in ln y, this is equals to minus n by 2. ln x is 0.31 plus 1 by 2 ln of c. Let me simplify. 1.12 equals to 0.31 divides 2. 0.31 divides 2, we have 0.155. Negative 0.155 n plus 1 by 2 ln c, right? The equation from the first point, this is my first equation. right? Now the second point, we have 1.06 and 0.19, right? Okay, so we have 0.91. This is equals to negative n by 2. 1.06 plus 1 by 2 natural log of c, right? Further simplification, 0.91 equals to we have 1.06 divides to 0.53 minus 0.53n plus half natural log of c. This is my second equation. Now let me subtract the two equations to get rid of this natural log of c and solve for n. So the two equations are 1.12, this is equals to minus 0.155n plus half natural log of c, and the other is 0.91 equals to minus 0.53n plus half natural log of c, right? Let me subtract the two equations. For subtraction, we have to change the signs, right? This is negative, this is positive, this is negative. So we can cancel the positive and negative. Okay, so we have 1.12 subtract 0.91. 0.21. This is equals to, we have 0.53 minus 0.155. 0.375. 0.375n, and to solve for n, we have 0.21 divides 0.375. 0.21 divides 0.375, 0.56. n is 0. Sorry, I did the mistake over here. I put the wrong point. The point is 1.21. So I put 1.12. Yeah, this is 1.21, 1.21, and over here 1.21. This is 1.21. Yes. Now let me solve this. 1.21 minus 0.91. This is 0.3. Okay, and 0.3 divides 0.375, 0.8. 0.8 is the n value. Now let me substitute the n value into first or second equation to get the c value up to 2 decimal place. They said the answer must be 2 decimal place, so this is just 0.8, or we can say 4 by 5. Yes, for n. Okay, now let me plug this n value into my first or second equation. Put in equation 1, we have 1.21 equals to minus 0.155, and value is 0.8 plus half natural log of c, right? Now let me simplify. We have times minus 0.155 equals to this 1.21 minus 0.124, and this is equals to half natural log of c. So we have 1.21 plus 0.124, this is equals to half natural log of c. 1.21 plus 0.124, 1.334. So over here, half natural log of c, this is equals to 1.334. 1.334, and natural log of c equals to 2 times of this, 2.668. 2.668, and c equals to e power 2.668, and shift e 2.668, we have 14.41 up to 2 decimal place. The c value is 14.41 up to 2 decimal place. So the C is 14.41 and the N value is 0.8. Question number 4, the parametric equations of curve R, we have x in terms of theta and y in terms of theta, show that dy by dx equals to this. So we have to use a chain rule to get dy by dx, right? So first we have to differentiate x with respect to theta, dx over d theta. So one derivative is 0, the derivative of cos is minus sine. So this is equals to sine theta, right? Now let's differentiate the function y with respect to theta. The derivative of cos is minus sine theta, minus 1 by 4. The cos derivative is again minus sine 2 theta into 2. So 2 times 2 is 4. So simplified form is minus sine theta plus sine 2 theta divides 2. Right. So now let me use a chain rule. Dy over dx is dy over d theta times d theta over dx, right? Okay, dy by d theta is this, so just substitute over here. So minus sine theta plus sine 2 theta divides 2. This is dy by dx times dx over d theta. So d theta over dx, we have to do the reciprocal. So 1 over sine theta. Right. Now let me divide the sine theta with both the terms. So over here, we have minus sine theta over sine theta plus 1 by 2. Sine 2 theta formula is 2 sine theta cos theta over sine theta. So sine theta cancel with sine theta, 2 cancel with 2, sine theta cancel with sine theta, right? So the only thing left is minus 1 plus cos theta. But we need the answer minus 2 sine square 1 by 2 theta, right? Okay, so let me open the cos double angle formula. If I use the cos double angle formula over here, cos 2 theta is equals to 1 minus 2 sine square theta, right? If I replace theta by 2, cos 2 theta by 2 is equals to 1 minus 2 sine square theta by 2. Right, so 2 is cancelled with 2, right? So we have, if I shift this one on the other side, minus 1 plus cos theta, this is equals to minus 2 sine square theta by 2. So minus 1 plus cos theta, so we can replace this with this term, right? So from here we can say that dy over dx is equals to minus 2 sine square theta by 2. This exactly match with this one. Dy by dx is minus 2 sine square half theta. Question number 5. The angles alpha and beta lies between 0 to 180 degree and are such that tan alpha plus beta is 2 and tan alpha is 3 tan beta. Find the possible values of alpha and beta. So let me open the sum formula for tangent. Tangent alpha plus beta equals to 2. Tan alpha plus beta is tan alpha plus tan beta, beta over 1 minus tan alpha into tan beta. This is equals to 2. If I substitute this value, tan alpha is 3 times of tan beta, right? So 3 times of tan beta plus tan beta, this is going to divide with 1 minus 3 times of tan beta into tan beta. This is equals to 2, right? So 4 plus 1, this is 3 plus 1, sorry, this is 4 tan beta over 1 minus 3 tan square beta. This is equals to 2. Right, now let's do the cross multiplication. 4 tan beta equals to 2 times 1 is 2, 2 times 3 is 6, tan square beta. Right? Shifting all the terms to the left side, we have a quadratic equation in tangent, 6 tan square beta plus 4 tan beta minus 2 equals to 0. Right? Dividing by 2, we have 3 tan square beta plus 2 tan beta minus 1, this is equals to 0. Right? So let me solve this by using quadratic formula or factorization. Right? So 1 times minus 3 is minus 3. Right? And 1 minus 3 gives me 2. Right? Okay, so 3 tan square beta plus 3 tan beta minus tan beta minus 1, this is equals to 0, the factorized form. Right? Okay, so let me take 3 tan beta common. We are left with tan beta plus 1. Let me take negative 1 common, tan beta plus 1, this is equals to 0. So the two factors are tan beta plus 1 and the other is 3 tan beta minus 1, this is equals to 0. Right? Okay, let me substitute both the factors separately equals to 0 to get the value for tangent. So from here we have tan beta equals to minus 1 and from the other factor tan beta is equals to 1 by 3. Right? So we have to find the value of alpha and beta between 0 to 180. Right? Okay. So if I can solve the first one, beta is tangent inverse of 1. We will do with the positive one first. And from here beta is tangent inverse of 1 by 3. Right? It is in degrees. Okay. Let me solve this in degrees. Let me convert my calculator into degree, and tangent inverse of 1 is 45. So here beta is 45 degrees, but tangent is negative over here. So we have to check tangent is negative in which quadrant. So let me draw the coordinate system here by using the cast rule. So if I use the cast rule, we have C, A, S, T, theta 180 minus theta, 180 plus theta, and 360 minus theta. So tangent is positive in first and third, but it is negative in second and fourth quadrant. And the domain is between 0 to 180 degree we have given, right? So we have to do only for the second quadrant when the tangent is negative. So we do 180 minus the theta value. So the only value of beta we will get in the second quadrant, which is beta is 180 minus 45. 180 minus 45, 135 degrees. This lies between 0 to 180 degree. Now let me solve the other one. Tangent inverse 1 by 3. This is here, the beta value is 18.4 degrees, and here the tangent is positive, so it is positive in the first quadrant and the third quadrant. So we are not dealing with the third one because third one is outside our domain, right? Okay, so we got the two values of beta. Let me find the corresponding values of alpha by using this equation, the given equation star. Tan alpha is 3 times of tan beta. Let me solve the value for alpha, right? Okay, so if I use here tan alpha is 3 times of tan beta. Beta is 135 degrees, right? Okay, tangent 135 times 3, that is negative 3. So from here tan alpha is negative 3 and alpha is tangent inverse of positive 3, and tangent inverse of 3 is 71.6. So alpha is 71.6 degrees, but tangent is negative in which quadrant? Let's see. So tangent is negative in second and fourth, again we use a second because of a restricted domain between 0 to 180, so we do 180 minus theta. So the only value of alpha is 180 minus answer. This is 108.43 or 108.4 degrees. 108.4 degrees, right? Now let me find the other one. Okay, so again tangent alpha is 3 times of tangent beta, which is 18.4 degrees, right? So tangent 18.4 times 3, we have tangent alpha is 0.997, and alpha is tangent inverse of 0.998. So tangent inverse of answer, this is alpha equals to 44.9 or 45 degrees, right? So the values of alpha that lies between 0 to 180, alpha and beta. When alpha is 108.4, beta is 135. When alpha is 45, beta is 18.4 degrees. Question number 6. Find the complex numbers w which satisfies the equation w square plus 2 iota w conjugate equals to 1 and such that real of w is less than equals to 0. Giving your answer in the form of x plus iota y, where x and y are real, right? So if I can suppose, let w is x plus iota y and w star is basically w conjugate, which is x minus iota y. Let me substitute this into the equation. So we have w square, equation w square plus 2 iota w conjugate equals to 1. So w square is x plus iota y whole square plus 2 iota and x minus iota y equals to 1, right? So opening the square, we have x square plus iota square y square plus 2 x y iota plus 2 iota x minus 2 iota square y equals to 1. And from here we know that iota square is equals to -1, right? So we have x square minus y square plus iota times 2xy plus iota times 2x, and iota square is -1, so plus 2y, and equals to 1. Yes. Okay, combining the real and imaginary parts. Real parts are x square minus y square plus 2y. This is a real part, and plus iota times the imaginary part is 2x plus 2xy. This is equals to 1, right? Now let me compare or equating the real and the imaginary part, right? Equating real and imaginary parts, right? Okay, so this part is real and 1 is real, and here the imaginary part is 0 iota. So we can say x square minus y square plus 2y, this would be equals to 1, real with real. And we have the second equation, imaginary with imaginary, 2x plus 2xy equals to 0, right? So if I factorize 2x, we have 1 plus y, this would be equals to 0, right? This is my first equation. Okay, from this equation we have 2x equals to 0, so the root is x is equals to 0, and 1 plus y is equals to 0, so y equals to -1, right? Okay, so let me substitute x equals to 0 into the first equation to get y, and y equals to -1 into the first equation to get x. Okay, so at x is equals to 0, what is equation 1? We have 0 minus y square plus 2y equals to 1, right? So taking or shifting all the terms to the right side, we can say. So y square plus 2y minus 2y plus 1, this would be equals to 0. Quadratic equation in a variable y. So we have y square plus minus 2y plus 1 is y minus 1 whole square equals to 0, or y minus 1 equals to 0, or y is equals to 1. right? So from here the value of x is equals to 0, y is equals to 1, right? Now let me substitute into this the second value. Okay, doing the other part, we have y is minus 1, so substitute into the first equation. We have x square minus minus 1 square plus 2 minus 1 equals to 1. So x square minus minus 1 square is 1, minus 2 equals to 1. So x square minus 3 equals to 1. So x square equals to 1 plus 3, this would be equals to 4, and x is equals to plus minus 2. The square root of 4 is plus minus 2, but we have a restriction that the real part of w means x must be equals to greater than equals to 0. Real part is basically x that is less than equals to 0, 0 or less than 0, right? So by using the restriction when x is equals to minus 2, because real of w is less than or equals to 0, negative 1 we have to select, right? Okay, now here again we have two values for x is minus 2 and y value is negative 1, right? So from here we have w, which we have supposed that x plus iota y, right? So what is x over here? X is 0 plus iota and the y value is 1. So here we can say w is equals to iota. The only value of w is iota. The second w is again x plus iota y. X we got minus 2 plus iota and the y we got is minus 1. So from here w is minus 2 minus iota. Question number 7, part A. By sketching a suitable pair of graphs, show that the equation 4 minus x square equals to secant of 1 by 2x has exactly one root in the interval 0 to pi. Okay, so if I consider the first function, what is secant? Secant half x. This is basically the reciprocal of cos, 1 over cos half x. Right? Okay, and what is cos x? Cos x graph is, if I sketch the graph of cos x over here, we know that cos starts with the maximum point of the graph of cos is 1 and the minimum point is minus 1 and its period is 2 pi, the one complete cycle. This is 2 pi is the one complete cycle, right? This is cos x, right? Now what is cos half x? Cos half x, right? This is a vertical stretch by a factor of the reciprocal of half, that is 2. So we can say that this is a stretch by a factor of 2 in x direction. Okay, so if it's a stretch by a factor of 2 in x direction, it means now the y stays the same between 1 to minus 1. The maximum and the minimum values are the same for the cos half x, but the period is going to be double. So 2x 2 pi, it becomes 4 pi, right? So if I draw the rough sketch and show you guys, so it again the maximum value is 1 for cos half x and the minimum value is minus 1, and one complete cycle is going to be this. Now this is your 4 pi, right? Okay, and one more thing, we know that cos x is 0 at odd multiples of pi by 2. Cos x is equals to 0 at odd multiple of pi by 2, right? We cos x is 0 at pi by 2, 3 pi by 2 and so on. So this is, we can say this is pi by 2, it is 0 at 3 pi by 2, right? Okay, now what is cos half x? Cos half x is going to be 0 at odd multiples of, again we have pi by 2 times 2 odd multiples of pi, right? So we can say that cos half x is equals to 0 at odd multiples of pi by 2 times 2 at pi, 3 pi, 5 pi, and so on, right? So it means this value is pi, this value is 3 pi, right? Now let me sketch this, the graph of cos half x first. Let me draw the sketch on a separate sheet of paper. If I can do from the middle, this would be better. Yeah. Okay. So first I would like to label everything, the x and the y's. X's. Yeah. So 1, we can say this is pi, 2 pi, 3 pi, 4 pi, minus pi, minus 3 pi, minus 2 pi, 3 pi, and this is minus 4 pi, right? Okay, and the maximum and the minimum values as well we have to sketch. So this is minus 1, 2, 3, 4, and 5. Downward minus 1, minus 2, minus 3, and minus 4. Okay, so this value is pi, 2 pi, 3 pi, and 4 pi, one complete cycle. Minus pi, minus 2 pi, minus 3 pi, and minus 4 pi. This is 1, 2, 3, 4, and 5. This is minus 1, minus 2, and minus 3, and minus 4 downward. So first I would like to sketch what is cos half x, right? So the maximum and the minimum values lies in this range, right? So if I draw the straight line, the maximum value is 1, right? And the minimum value is minus 1. The graph is between the points. Okay, and cos half x, we know that cos x is 0 at odd multiples of pi by 2, so cos half x is going to be 0 at odd multiples of pi, 3 pi, 5 pi, but its period is 4 pi, so we have to stop at 4 pi, right? Let's start from the maximum. It is 0 at pi, at 3 pi, right? Okay, so maximum pi, this is 2 pi, 3 pi, and one complete cycle, 4 pi. So this is a graph for cos half x, right? Okay, now we have to do the reciprocal. The reciprocal of cos half x is secant half x, right? Okay, and if we draw on the other side as well, it has same minus pi, minus 3 pi, it is 0, and this is 2, and this point. Let me connect all of them. Okay, the two cycles basically. Okay, so now what we have to do, so if let's do the reciprocal of cos half x. This is cos half x. Now the reciprocal of cos half x is secant half x. So if I'm doing the reciprocal between minus pi to plus pi, let me show you the reciprocal between minus pi to plus pi, because we know that at minus pi and at plus pi cos is equals to 0, right? When cos is equals to 0, secant is undefined, right? So we can say that cos x is equals to 0 at x is equals to pi and minus pi. Cos half x, sorry, this is equals to 0 at pi and minus pi. So when it is 0, so it means that secant half x, this is undefined, because secant is a reciprocal, so it is undefined, so it is asymptotic at that point, right? Okay, so this is a sketch, so we have to draw the sketch, the reverse, right? Okay, this one is common. So the sketch between minus pi to plus pi is just a shape of a parabola, right? This is the shape of the parabola. Okay, so let me do the reciprocal of this parabola. this is going to be the sketch for secant half x. Right. Now the second thing we have to do is the equation, this line, the parabola, sorry, 4 minus x square, right? So if I consider this function, we can say that let y is equals to 4 minus x square, right? So let me solve the x-intercept. It's a parabola, obviously. So let me do the x-intercepts and the y-intercept, right? At x is equals to 0, what is y? Y is 4, y-intercept is 4, and at y is equals to 0, we have 4 minus x square would be 0, and x square equals to 4, and x is equals to plus minus 2. So the x-intercepts are positive 2 and negative 2, and the y-intercept is equals to 4. So let me sketch this. Y-intercept is 4, and the x-intercept is 2 and minus 2, right? So what is pi? We know that pi value is 3.14, right? 3.14 is a pi value, but so it is 2 is over here, 2 and minus 2, we can say. So let me sketch this parabola. Its opening is downward because x square coefficient is negative. So let me connect the points. So if I can say this is another x-intercept passing through the y-intercept. Okay. Okay, this is a curve for a parabola, and this is a sketch for secant half x, right? So the question was, by sketching a suitable pair of graphs, show that these two are equal, has exactly one root between 0 to pi. Has exactly between 0 to pi is this interval. So it has, this is a curve and this is a curve. So it has exactly one root, and this point is the root. We just have to show, there is no need to find the root, but just have to show that between 0 to pi, the two pair of graphs have only one root. Part B, verify by calculation that this root lies between 1 and 2. So if the root lies between 2 points, it means the sign change occur, right? If root lies between 2 points, sign change occur. What is sign change? Means the function differs the sign between the 2 points, from positive to negative or negative to positive, right? So this is the function. If I can rewrite this function as f of x is equals to 4, we have 4 minus x square and minus secant half x. This is the function. So what is f of 1 and what is f of 2? Right, so 4 minus 1 and 4 minus 2 square, we have 1 square, minus secant 1 by 2 times 1 minus secant 1 by 2 times 2. So we can cancel the 2. So we have, if I can simplify, secant half. Secant is a reciprocal of cos. We can do in radians because the domain is in radians for question number 1. Okay, so cos 1 by 2 is this, and minus 1 divides answer. Sorry. First we have to find cos of half. Cos half is 0.8775, and the reciprocal 1 divide answer times by negative 1 is this. So the answer for secant half x is going to be this, and 4 minus 1 is 3, so plus 3. The first answer is 1.860. Now doing the second one, secant of 1, so we do cos 1 and its reciprocal and times by negative 1 because it is negative secant 1, and 4 and minus 2 square is 4, so positive 4 and negative 4, 2 square is also 4, it's 0. So the answer is minus 1.850. So as you can see that the sign change occur over here, so we can the function change the value from positive to negative. So it means that the root lies between root lies between 1 and 2. Now for part C, use the iterative formula xn plus 1 equals to square root of 4 minus secant of half xn to determine the root correct to 2 decimal place. Give the answer of each iteration up to 4 decimal place. Okay, so we have to consider the initial guess. You can take the initial guess as 1 or 2 because we know that the root lies between 1 and 2. So if I can say that x1, this is going to be 1. What is x2? And x1 plus 1. So this is equals to square root of 4 minus secant of 1 by 2 times 1 and square root. Up to 4 decimal place we have to solve. Okay, so we have secant 1 by 2. First we need to simplify. Secant is half 1 by 2 and the reciprocal 1 over answer, right? And times by minus 1 and plus 4 and doing the square root. 1.6913 up to 4 decimal place. 1.6913. 1, 2, 3, 4. Yes. Now for next is x3. This is square root 4 minus secant half of this 1.6913 and the square root. Right. This is going to divide by 2 and cos of answer, and the reciprocal would be secant and 4 subtract answer and the square root. 1.5 7 8 and 5 7 8 and this round to 7 up to 4 decimal place, right? Okay, now the next is x4. 4 minus secant half of 1.5787 and its whole power is 1 by 2. We can put 1 by 2 instead of square root. Okay, so dividing by 2, cos of answer, doing the reciprocal to get secant, 4 subtract answer and the square root. 1.6063. 1.6063. Okay, the next x5, the fifth iteration, we have 4 minus secant half 1.6063 power 1 by 2, right? So this is going to divide by 2 and taking cos of that answer and doing a reciprocal to get secant, 4 subtract answer and the square root of answer. 1.600. 1.600, right? And 0 0 0. Okay, now we have to find the root up to 2 decimal place. So as you can see, 1.6, if you round this, we have 1.6 1.6 1.6, right? And we have 9700. So if we continue, so the root converges to, root is basically 1.60, right? So this is a root. Question number 8, part A. Find the quotient and remainder when a polynomial, a cubic polynomial, is divided by 4x square plus 1, right? So let me do a long division method. Right. We have 4x square plus 1 and 8x cube plus 4x square plus 22x plus 7, right? So 4x square and we have 8 cube. So 4 times 2 is 8 and x square times x is x square. So 8x cube and plus 2x, right? Let me subtract this. Negative and negative. So as you can see, 8x cube, positive and negative is cancelled, 2x, positive and negative is cancelled. We are left with 4x square and plus 7, right? So if I add 1 here, we have 4x square plus 1, again subtract 4x square positive and negative is cancelled, and 7 minus 1, this would be equals to 6. So the quotient is 2x plus 1 and the remainder is 6. So we can say that quotient is equals to 2x plus 1 and the remainder, this is equals to 6 for this polynomial division. Part B, hence find the exact value of this integral when a polynomial is divided by 4x square plus 1, right? So this is basically 0 to half 8x cube plus 4x square plus 2x plus 7 divides 4x square plus 1 dx. We can rewrite as first quotient 2x plus 1 plus the remainder over the divisor. This also integrate with respect to dx between the limit 0 to half, right? Okay, so here we can say 2 is outside, the integration of x 0 to half dx plus the integration from 0 to half 1 dx, right, plus 6 is outside, the integration of 1 over 2x whole square plus 1 square with respect to dx, right? So which formula we have to use for the integration over here? So as we know that integration of 1 over a square plus x square is 1 over a tan inverse of x by a, right? And the derivative of x, d by dx of x, that is just 1. Okay, so let me use the formula. So we have 2, integration of x is x square by 2 plus integration of 1 is just x plus 6, its integration is 1 over a value is just 1, tan inverse of x value is 2x over a, which is 1, and the derivative of 2x is just 2, which is going to divide, sorry, because it is integration. In differentiation we have to multiply, yes. Okay, so 2 is cancelled with 2 times 3 is going to be 6. We have x square plus x plus 3 tan inverse 2x, right? And it is a definite integral 0 to half. We have to substitute the limits, upper and the lower limits, right? So let me substitute the limits first. So the upper limit is 1 by 2 square plus 1 by 2 plus 3 tan inverse 2 times 1 by 2. This is the upper limit minus lower limit is 0 plus 0, and what is tan inverse of 0? I guess it is 0 plus 3 tan inverse of 0. Tan inverse of 0, it's 0, whether it is in degrees or radians. Yeah, 2 is cancelled with 2. We have 1 by 4 plus 1 by 2 plus 3 times tan inverse of 1 is 45 degrees, or if we can do in radians, tan inverse 1 is pi by 4. Yes, pi by 4. The rest of the terms are just 0. What is 1 by 4 plus 1 by 2? 3 by 4, right? So this is 3 by 4 plus 3 by 4 pi. Let me take 3 by 4 common. We have 1 plus pi is the answer for this integral, definite integral. Question number 9, the variables x and y satisfies a differential equation. This is a differential equation. It is a separable differential equation. And it is given that y is 1 when x is 1. Okay, solve the differential equation and find the exact value of y when x is equals to 3, giving your answer in the simplified form, right? So this is a separable equation. Let me convert this into the form. So we have 1 by y dy stays the same. I just divide the y over here, and dx is multiplying and this term is dividing. 1 over x plus 1, 3x plus 1, and dx. and we have to integrate. This is a separable equation, right? So before doing integration, if I can say that this is my equation number 1, so we have to apply the partial fraction over here, right? So we can say that 1 over x plus 1 into 3x plus 1, this is basically equals to a over x plus 1, the first factor, plus b over the second factor, 3x plus 1, right? Okay, so if I can multiplying both sides by x plus 1 and 3x plus 1. So here we are left with 1, a times 3x plus 1 plus b times x plus 1, right? So let x is equals to minus 1. So I just substitute x plus 1 equals to 0. We got the first root x equals to minus 1. So we have 1 is equals to a. We have minus 3 plus 1. So this is minus 2. So 1 minus 1 by 2. This is my a value. B we will get 0 because minus 1 plus 1. This is going to be 0, right? Now the second factor, let x is equals to minus 1 by 3. Right, so when x is minus 1 by 3 put into this equation, we have 1 is equals to a, this is going to be 0, plus b, we have minus 1 by 3 plus 1. Okay, so what is 1 minus 1 divides 3 plus 1, which is 2 by 3, right? So we have 1 is equals to b into 2 by 3. So what is b? The reciprocal of 2 by 3 on the other side. So from here b is 3 by 2. So we have the a value, which is 1 minus 1 by 2, and the b value is 3 by 2. Let me substitute that value into the partial fraction, right? So we have 1 over x plus 1 into 3x plus 1. This is equals to a, which is minus 1 by 2 into x plus 1, plus b, which is 3 by 2 into 3x plus 1, right? Let me plug this answer of partial fraction into my equation number 1. So if I can rewrite my equation 1, we have, you can say, the integration of 1 over y dy. This would be equals to, we have minus 1 by 2 and 3 by 2. The integration, minus 1 by 2 is outside. The first root is 1 over x plus 1 dx, plus 3 by 2 is outside, and the second root is 1 over 3x plus 1 dx, right? Okay, the integration of 1 by y is ln of y minus 1 by 2. Here ln of x plus 1, x derivative is 1, which is in the numerator, plus 1 by 2. The derivative of 3x plus 1 is 3, so which is at the top. So we can just write down ln of 3x plus 1. And we have some constant of integration, let's say c, because this is not a definite integral. To get the value of c in the question, we have given the condition that when y is 1, x value is also equals to 1. So we can easily find the value for the c, right? So let me substitute the condition. When y is 1, ln of 1, this is equals to minus 1 by 2. Ln of x is also 1, which is 2, plus 1 by 2. Ln of 4 plus c, because 3 plus 1 would be equals to 4, right? So ln of 1 is 0. Let me show you guys. Ln of 1, this is equals to 0. So this side is going to be 0. Okay, 0 equals to minus 1 by 2. Ln of c, 2, plus 1 by 2. Ln of 4 plus c. Okay, so what is the value for c? So c value is basically shifting these two terms on the other side, which is 1 by 2 ln of 2 minus 1 by 2 ln of 4, right? C is taking 1 by 2 common. We have ln of 2 minus ln 4. So applying the division property here. So c is 1 by 2 ln of 2 by 4. Right, so 2 times 1 is 2, 2 times 2 is 4, so this is 1 by 2. So c value is 1 by 2 ln of 1 by 2, or we can rewrite this 1 by 2 ln of 1 minus ln of 2. Ln of 1 is equals to 0, so C is equals to minus 1 by 2 ln of 2. So let me plug the value of C into my equation. So ln of y, this is equals to minus 1 by 2 natural log of x plus 1 plus 1 by 2 natural log of 3x plus 1 minus 1 by 2 natural log of 2, right? And the question says we have to solve the differential equation and find the exact value of y when x is equals to 3. So we have to solve for y basically. Okay, and then get rid of this natural logs, right? Okay, so 2, 2, 2, taking 1 by 2 common, times by 2, natural log of times by 2 on both sides basically. So minus ln of x plus 1 plus ln of 3x plus 1 and minus ln of 2, right? Okay, so further simplification we can say, let me substitute the condition. We have to solve for y when x is equals to 3. So at x is equals to 3, you can say 2 natural log of y equals to minus ln of 3 plus 1 4 plus ln of 3 times 3 is 9, 9 plus 1 is 10 minus ln of 2, right? Okay, so we have ln of 10 minus ln of 4 plus ln of 2, right? Ln of 10 minus, we have a product ln of 4 times 2, this would be equals to 8. So 2 natural log of y equals to natural log of 10 minus natural log of 8, right? Now we have to use a division property. Okay, so 2 natural log of y equals to natural log of 10 by 8, right? And natural log of y square is equals to natural log of 2 times 5 is 10, 2 times 4 is 8. Taking anti-log on both sides or cancelling natural log, we have y square is equals to 5 over 4, and the value of y, this is equals to square root of 5 by 4. Or further simplification, we have 1 by 2 square root of 5. This is the value for y. Question number 10, the points A and B have a position vector this and this respectively. The line L has a vector equation R equals to this. Find the vector equation from the line through A and B. So vector equation is basically R equals to the position vector plus some constant k times the direction vector, right? So first we have to find the vector equation of line through A. So we can say line A, we have R equals to OA plus some constant k times the direction vector is AB, which is B minus A. So R is equals to OA. The point A and B have a position vector. A has this position vector 2i plus j plus k. The constant is, let's say, lambda, and AB is basically B minus A. So if I can solve AB, which is equals to OB minus OA. What is OB? This is OB, which is 1 minus 2 and 2 minus OA 2 1 1. Okay, so 1 minus 2 is minus 1 minus iota and minus 2 minus 1 is minus 3j, and 2 minus 1 is 2 minus 1 is just 1 k. Yeah, this is a velocity equation of line through A, and the velocity equation of line through B, which is R is equals to OB plus some constant k times AB, the direction vector. So we can say R is equals to OB is this I minus 2j plus 2k plus lambda times of AB, which is minus I plus 3 minus 3j and plus k. So these are the vector equation of line through A and through B. Now moving to part B, find the acute angle, the angle which is less than 90 between the directions of AB and L, giving your answer in degrees. Okay, the directions. What are the directions of AB and the directions of L? So this is a direction for line L and this is a direction for AB, right? So we can say that the line AB, you can use through A or through B, this is your choice. So the line AB is, we can say R is equals to 2I plus J plus K plus lambda times minus I minus 3J plus K. And the line L is R is equals to I plus 2J minus 3K plus mu times I minus 3J minus 2K. Okay, so these are the directions, right? So we have to pick the directions first and using the formula of the directions. So if I can say this is a direction A and this is a direction B, so the formula for the when to find the angle between the two directions, we have cos theta is the product of the two directions divides the magnitude of the two directions, right? So let me substitute this. Cos theta is equals to, the first direction is minus 1, minus 3 and 1. So minus 1, minus 3 and 1, and its product with dot product 1 minus 3 minus 2, 1 minus 3 minus 2. This is going to divide with the magnitude of this, the first direction, 1 square, 3 square and 1 square, and the square root. 1 square is 1, 3 square is 9 and 1 square is 1. So square root of 11 product, and the square root of the second one, 1 square is 1, 3 square is 9, 2 square is 4, 14. So the product of 11 and 14 is 154. And we have cos theta is equals to, and we do the product as well, 1 times minus 1 minus 1, 3 times 3 plus 9, 1 times minus 2 over square root of 154. Okay, so 9 minus 3, 9 minus 3 is just 6. Yes, so this is equals to 6 over square root of 154. Now let me solve for theta. Cos inverse of 6 over square root of 154. The angle must be acute and should be in degrees. My calculator is in radians. Let me convert it into degrees first. And doing cos inverse of 6 divides square root of 154. 61.08. So we can say that 61.1 degrees. This is acute angle between the directions of AB and L. Now for part C, show that the line through AB does not intersect the line through L, right? So first we have to write down the line through AB. What is the line through AB? So this is a line through AB. So if I can write this line as R is equals to 2 minus lambda, 1 minus 3 lambda and 1 plus lambda. This is the line through AB. You can see 2 and minus lambda, 1 and minus 3 lambda and 1 plus lambda, right? And the line through L, which is R is equals to, we have the line 1 plus mu, 2 minus 3 mu and minus 3 minus 2 mu. Okay, so if it does not intersect, it means the lambda is not equals to mu, right? So we have to equate this and put both of them equal. Comparing, we will get 3 equations. We can say 2 minus lambda, 1 minus 3 lambda, and 1 plus lambda. This line is equals to 1 plus mu, 2 minus 3 mu, and minus 3 minus 2 mu. Right. So let me equate and make the two equations. 2 minus lambda equals to 1 plus mu. So we can say that 2 minus 1 equals to lambda plus mu. And from here we have an equation lambda plus mu. This is equals to 1. This is my first equation. Right. Now comparing the second components, we have the second equation. We have 1 minus 3 lambda equals to 2 minus 3 mu. 1 minus 2 equals to minus 3 mu plus 3 lambda. Minus 1 equals to minus 3 mu plus 3 lambda. Or we can say that if I shift this one on the other side to make it positive, and the rest of the terms over here, so we can say 3 mu minus 3 lambda, this is equals to 1. This is my second equation, sorry. Right. Now let me make the third equation. By comparing the third component, we have 1 plus lambda equals to minus 3 minus 2 mu. 1 plus 3 equals to minus 2 mu minus lambda. 4 equals to minus 2 mu minus lambda. This is my third equation. Right, so let me solve the values of lambdas and mu. So first equation is lambda plus mu equals to 1. 3 mu minus 3 lambda equals to 1. So if I multiply first equation with 3 and then add in equation number 2. Let me do this. The equation 1 is multiplying with 3. So 3 lambda plus 3 mu equals to 3, and minus 3 lambda, equation 2, plus 3 mu is equals to 1. Right, now let me add the two equations to get the value of mu. Right, so adding the two equations, 3 lambda minus 3 lambda is cancelled. 3 plus 3 is 6. Mu equals to 4, and the mu value is 4 out of 6, or we can say that 2 out of 3. This is the mu. Now let me substitute the value of mu into the first equation to get lambda. The first equation is lambda plus mu is equals to 1. So lambda is equals to 1 minus mu, that is 2 by 3. 1 minus 2 by 3. 1 minus 2 by 3. This is 1 by 3. So lambda is 1 by 3 and the mu is 2 by 3. Okay, now let me substitute the values of lambda and mu into equation number 3. Put lambda and mu in equation number 3, and let's see if the both sides are satisfied. It means the lines intersect. Equation 3 is 4 equals to minus 2 mu minus 2 lambda. So minus 2 mu minus lambda equals to 4. Right, minus 2, and the mu value is 2 by 3. This is 2 by 3. Minus lambda is 1 by 3 equals to 4. Right, so minus 4 by 3 minus 1 by 3, this is equals to 4. Right, so if I can simplify, so this is minus 5 out of 3, this would be equals to 4. Minus 5 by 3 is not equals to 4, so the both sides of the equation is not satisfied. So we can say that the line through AB does not intersect the line through L. Right. Question number 11. The diagram shows the curve y equals to sine x cos 2x for x is between 0 to half pi, and its maximum point is m. So m is the maximum point of the curve. Right. Part A, find the x coordinate of m, giving your answer correct to 3 significant figures. X coordinate of the maximum point. Right, so for the maximum point, we know that we have to differentiate the curve and put the derivative equals to 0 for maximum point. Right, so for maximum or the minimum point, what we have to do, we have to differentiate the curve dy over dx and put the gradient equals to 0 and solve for the x coordinate only, right? So let me differentiate this curve. So we have to do the product rule over here, right? So the product rule, sine x is as it is. The derivative of cos 2x, cos derivative is minus sine 2x into 2, plus cos 2x is as it is, and the derivative of sine x is cos x. This would be equals to 0, right? So we have minus 2 sine x sine 2x plus cos x cos 2x. This would be equals to 0, right? Okay, and if I open this formula for sine 2x, we have minus 2 sine x 2 sine x cos x plus cos x cos 2x. This would be equals to 0, right? Okay, let me simplify it further by taking cos x common, because cos is common on both terms. So cos x is common. We have minus 4 sine square x, 2 times 2, 4 sine times sine square, plus cos 2x. This would be equals to 0. So from here, cos x is equals to 0. Cos x is basically equals to 0 at odd multiples of pi by 2. So we have, and the other term we can say cos 2x minus 4 sine square x. This would be equals to 0. If I open the, okay, let me solve cos inverse of 0, which is 90 degree, right? So odd multiples. So this is pi by 2. So we are considering the maximum point. So it is, the function is not 0. So we are not getting anything from here. So open the formula of cos 2x in terms of sine, because we have a sine, so sine square over here, right? So cos 2x is basically 1 plus 2 sine square x, 1 minus 2 sine square x, minus 4 sine square x. This would be equals to 0. So we have 1 minus 6 sine square x. This would be equals to 0. And we have sine square x would be equals to 1 out of 6, right? And again we have two values for sine. Sine x is plus minus 1 over square root of 6, right? So we have to consider the positive one and the negative one, right? So if I have sine x is 1 over square root of 6, and the other sine x is minus 1 over square root of 6. So what is x? Sine inverse of, this must be in radians. My calculator is in degrees. Let me convert it into radians. Okay, sine inverse of 1 divides square root of 6. 0.420. We have to find the answer up to 3 significant figures. 1, 2, 3. So 4, 2, 1. 0.421, right? And this is positive, so we have to consider between 0 to the domain is between 0 to pi by 2, right? Okay, and sine is negative in which quadrant? Sine is negative in 3rd and 4th, so we are not considering this one. Not in domain, right? So the only x coordinate for the maximum point is equals to 0.41. So this maximum point is 0.421, the x coordinate of this point. The x is over here, right? Now for part B, using the substitution u equals to cos x, find the area of the shaded region enclosed by the curve and the x-axis in the first quadrant, giving your answer in the simplified exact form. Okay, area of the shaded region we have to find. As you can see, this is a shaded region. So the shaded region is enclosed by the curve and the x-axis in the first quadrant. So basically we have to integrate the curve between the limit x equals to 0 to this point, right? So we have to find the other 0 for this curve, right? So we have a curve sine x and cos 2x. We know that sine x is equals to 0 at what values? At x is equals to 0, pi, 2 pi, and so on. So it is 0 at 0, but it is the value should be lower than half pi, so we are not considering this. And what is cos 2x? Cos 2x is equals to 0 when at cos is 0 at odd multiples of pi by 2. So we have pi by 2, 3 pi by 2, 5 pi by 2, and so on. So at x is equals to pi and 3 pi and so on, right? Sorry, pi by 4 we have to divide. Yeah, 3 pi by 4. Okay, so pi by 4 is the number that is lower than half pi. 3 pi by 4 is more than half pi. So this point is pi by 4. So we have to basically integrate this curve between 0 to pi by 4, and using the substitution that cos x would be equals to u, right? So let me do this. So we have to, in the area, the shaded area is basically the integration between 0 to pi by 4 of the curve sin x cos 2x dx, right? Okay, now using the for using the substitution, what we have to do, we need to open the formula for cos 2x. So this is 0 to pi by 4 sin x. Cos 2x is 2 cos square x minus 1 and dx. This is 0 to pi by 4 sin x, and let me use a substitution here, which is given that u must be equals to cos x. So if u equals to cos x, what is du? Du is minus sin x dx, right? And x dx is replacing with du, right? So we have to change the limits at x approaches to 0. When x approaches to 0, u approaches to cos of 0. Cos 0 is 1, right? It is in radians, yes. At x approaches to pi by 4, what is u approaches? U approaches to cos pi by 4. Cos pi by 4, which is 1 by square root of 2. Right. Now let me use the substitution into this integral. So we have the shaded area is going to be integrate between 1 to 1 over square root of 2, right? And we have 2 cos square is u square minus 1, and sin x dx is minus du. And we have to take this minus sign outside because the lower limit is more than the upper limit. So here we have to change the 1 over square root of 2 to 1, 2u square minus 1 and du. Right, now just do the integration, the simple integration we have. So here we can say 2u cube over 3 minus u, and the limit is between 1 over square root of 2 to 1. Right, now let me substitute the upper and the lower limit to get the shaded area. Shaded area is going to be 2 by 3. The upper limit is 1 cube minus 1. Subtract the lower limit is 2 by 3. The cube of 1 over square root of 2 whole cube minus 1. Right. Simplified further, we have 2 by 3 minus 1 from the upper limit, minus we have 2 by 3, and what is okay, let me simplify this. Square root of 2 and its whole cube. So 2 square root of 2 minus 1. 2 is cancelled with this 2, and 1 by what is 2 by 3 minus 1, which is minus 1 by 3. This is equals to minus 1 by 3 and minus 1 over 3 square root of 2 minus 1, right? And further simplification, if I can say that minus 1 over 3 minus 1 over 3 square root of 2 and plus 1, minus times minus is plus, so minus 1 by 3 plus 1, this is 2 by 3. 2 by 3 minus 1 by 3 square root of 2, right? Or if I can take 1 by 3 common, 1 by 3 is common, we have 2 minus 1 over square root of 2. I did the mistake here by putting the limit. This is 1 over square root of 2, sorry. 1 over square root of 2, this is 1 over square root of 2, and plus 1 over square root of 2, right? We cannot do the last step, right? Okay, instead of this step, what we have to do, we need to simplify the square root terms. First, minus 1 by 3 is outside, plus 1 over square root of 2, right? And what we have to do, we have 1 and minus 1 by 3. Minus 1 divides 3 and plus 1, this is 2 by 3, right? Let me simplify this further. So this is minus 1 by 3 minus 1 over square root of 2. We can rewrite this square root of 2 into square root of 2 over 3. We can cancel the square root of 2, minus 1 over 3 minus square root of 3 over square root of 2 over 3, sorry, right? And if I can take so this was plus. Let me take 1 by 3 common. So we have square root of 2 minus 1. This is a simplified answer. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.